Hello and welcome to the first experiment of the DSA lab, which is implementation of stack and its application in an array. So this is the first program where we implement a stack. So we've created our private variables, which is basically the size, the top of the stack and the stack size. We have a function, a constructor to initialize our variables. We have function boolean is empty to check whether it's empty, and is full, which is, as the name suggests, will check if it's full, to push, pop, and display, and finally to print top of the stack. So here we dynamically initialize the size to s, and top initialized to -1, and our stack says basically store capacity -1. That's it. So this function checks whether our stack is empty. This one will check whether it is full. Basically, we check if its top is equal to the stack size, so we return true, else we return false. This is to push a value onto the stack, which is if is full is true, then we cannot push anything onto the stack. Otherwise, we increment top first and then we insert the value. So this is the pop function where we check whether it's empty. If it's empty, then there's nothing to pop. Otherwise, we first store the element in which we want to delete in value, and then decrement top. Display will basically display the stack from top till greater than equal to 0, and stack top will give us the top of the stack, which is basically s of top wherever top is during its execution. And we have a menu driven program here which allows the user, we are creating an object here to call these functions, so we ensure that this is object oriented. So we provide the user with a choice, and let us look at how this executes. So first we enter stack size, let's say 3, so we perform an operation of push, say 1, and again we push an element, say 2. Now we'll display our stack, which is basically 2 and 1, as you can see here, and we check if it's full. So as you can see, we entered only 2 elements, therefore it's not full. So now if you were to pop, the element popped will be 2. So this is the execution of our first program. Moving on to the second program of this exercise, where we show the application of stacks, which is basically converting an infix expression to a postfix. So our functions remain the same, which we had in the stack program. And here lies our the main code, which is basically we are checking precedence in this. So we check the precedence accordingly, and we return the current operand in execution. And let's take a look at how that executes. So if you enter, so as you can see, this gives us an evaluated expression and converts the infix to postfix. Experiment 1 is complete and the output is verified. Thank you.